and is very thin. It's less than a millimeter thick. Thousands of these usually come out of one single crystal. Now the wafer would then be polished to an absolutely flat surface, better than most mirrors, a mirror polish. And then what we have is called a wafer, and this is the sort of the raw base building material for making chips. Now, what happens is the wafer is put into a process that's a photolithographic process. We take a mask, which is, could call it like a negative. We shine a light through it, and we literally etch the various dye into the wafer. I'm going to show you an example here. This is an example of a wafer that has 177 finished die etched into it. As you can see, they're just one after the other, rows and rows and rows of them. One mask was used to produce this, or I should say one collection of masks, because each of these die is not just one image that's put on this wafer. It's a stacked series of images, usually 20 or more layers. And through the photolithographic process, material is coated onto the wafer, then it is etched with the ultraviolet laser, then portions are washed off, and we literally have like a cake building process, a layer upon layer upon layer, until this very complicated series of circuits is assembled. Then, once the wafer is complete, the individual die are then cut out of it. So we end up with individual square processor die. Now, a typical die, might be something on the order of these sizes here. I have I made up some pieces of paper that are about the size of most modern processor die. They can be anywhere from usually 10 millimeters to 20 millimeters square on each side. Some are more rectangular, some are square. Okay, so now we've seen the basic, building process of making processors, but let's take a look at how this technology has changed over the years. Processors have been made for nearly 40 years now. The first one came out in 1971. What was different, from then to now? Well, a couple of things that have changed. One is the size of the wafers. This is an example wafer from around 1973-74 when they were 3 inches in diameter. As you can actually see, this one has a series of chips imprinted on it. This one was never cut. The chips were never cut out into the separate die. Now, wafer sizes have increased over the years. Most recently, we had a transition from 8-inch wafers to 12-inch wafers. And what that means is that the wafers that are being used for most chips today are 12 inches in diameter. Now, as the wafer size increases, the number of chips that can be imprinted on them go up. For example, this wafer image that I have here was actually originally an 8-inch wafer. And with the 8-inch design, 177 separate chips could be etched or fit onto this wafer. Well, when this was increased to 12 inches, they began making the same chips on a 12-inch wafer. They were able to make 449 chips on the same exact wafer. So in the same amount of time, they are now making, nearly or more than twice as many chips. As the wafer size went from 8 inches to 12 inches, the surface area grew grew 2¼ times. So we can have literally more than double the number of chips being produced. So these are some of the technology changes that have happened. The wafers have gotten bigger. One other thing has been going on, though. The componentry that goes into each of these die has become smaller and smaller. When processors were first being made, the very first processor in 1971 had components spaced 10,000 nanometers apart. That's 10,000 billionths of a meter. Today, we are making chips with the componentry spaced only 32 nanometers apart. That's hundreds of times more dense, more components fitting into the same space. So while the die